There are four common problems that student teams encounter when using PCCs. The first is with internal consistency, an error. This presents itself as a tie in the totals column. The second problem is one where the team just can't decide which objectives they feel are most important. This manifests itself with fighting or debating over which objective may be the most important. The third problem is one where you have an embedded constraint that you used in your pairwise comparison chart instead of an objective. And as you'll see, the constraint always wins. The fourth problem with the PCC the student teams encounter is with a real tie, when two objectives truly do deserve to be considered with equal importance. Internal consistency is a transitive property that says that if objective A is greater than objective B, and objective B is greater than objective C, then objective A must be greater than objective C. Let's look at a PCC that has an internal consistency error. Notice, as we mentioned before, there's a tie that's shown in the totals column. Take a minute and try and find the internal consistency error in this table. Hopefully you found the error. Cost is greater than aesthetics. Aesthetics is greater than temperature. And the error is that temperature is greater than cost. Based on the transitive property, cost should be greater than temperature. When this error is fixed and temperature is greater than cost, the totals column reflects the correct results.
A second problem that your team may encounter is that you may feel that 2, 3, or more objectives are equally important. This often manifests itself when completing the PCC that your team is arguing back and forth, and you can't resolve which objectives are more important. If this situation is to arise, you need to go back and talk with the clients and the users. You need to ask them difficult questions and ask them which objectives are more important than the others. Then, with this newfound information, you want to come back and complete your PCC.
The third problem that student teams encounter when working with PCCs is one with embedded constraints. If you remember back to our conversation about designing the water bottle, users said they wanted the water bottle to be safe. Water bottles must be safe all the time, not some of the time. As you'll see in the next PCC example, the constraint will always win against design objectives. If you look at this PCC, you can see that we have included safe as an objective along with our other 5 design objectives. Viewing the totals column, safe has won out against all other design objectives. This is the first indication that you have an embedded constraint. This problem can be solved by removing safe from the PCC and placing it in the constraints category. Just because something ranks as first does not necessarily mean that it is a constraint. If we look back to our chart, you can see that ease of use also has ranked first. But ease of use is an objective. That is, if your water bottle is only moderately easy to use, it still could succeed in the marketplace. Whereas if you had an unsafe water bottle, it would never make it to market.
The fourth problem that your team may encounter is an actual tie. This situation might occur when you've talked with your users and your client, and they emphasize over and over again that 2 objectives really are of equal importance. So it is okay for a team in one situation to allow an actual tie when constructing their PCC. In this case, you convert the 0 and 1 to a half and a half. So when you look at the table, you'll see ease of use is 4, durability and cost each is 2.5, aesthetics is 1, and maintained temperature is 0. When you convert these in step 5 to the ranked solutions, you'll then see ease of use on top in position 1, durability and cost tied in position 2, aesthetics ranked 4th, and maintained temperature as 5.
Pairwise comparison charts are helpful tools that design teams can use to identify the most important objectives. When completing pairwise comparison charts, teams may run into up to 4 different problems. These problems can be solved in one of 2 different ways. The first is with greater communication within teams and also with clients and users to identify the objectives. The second way is to just make sure that when you complete your PCC, you do it carefully and with consistency. Having finished your PCC, design teams can move on to identify their design criteria and begin to select solutions.